the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on acid-base concepts. In our last lesson, we discussed the concepts of Arrhenius. We learned that Arrhenius defined an acid as a substance that releases a hydrogen ion or proton or a hydronium ion in aqueous solution. He defined a base as any substance that ionizes or dissociates in aqueous solution to release hydroxide ion. We learned about some common examples of each. We also discussed how hydrogen ions release from acids and bind to water molecules, and how hydroxide ions release from bases in water solutions. In today's lesson, we will define acids and bases according to the Bronsted-Lowry concept. We will look at some examples of each, and we will show the transfer of protons or hydrogen ions in acid-base reactions. Students, if you are ready, we will begin. In 1923, a broader and more inclusive definition for acids and bases was presented by Johann Bronsted and Thomas M. Lowry. According to their definition, acids are substances that donate protons to some other substance. Let us look at some examples. When hydrochloric acid ionizes in water, hydronium ions and chloride ions are formed. When ammonia and water react, they form ammonium plus and hydroxide ion. This is a reversible reaction. When phosphoric acid and water react, they form hydrogen phosphate 2- and hydronium ions. This is also a reversible reaction. HCl in the first, water or H2O in the second, and phosphoric acid, or H3PO4 in the third reaction, are Bronsted-Lowry acids. This is because they behaved as proton H+ donors. Students, the Bronsted-Lowry concept of acids furthered the Arrhenius concept because it includes molecules or species that do not release hydrogen or hydronium ion in aqueous solution, as well as those proton donors in non-aqueous solution. For example, hydrochloric acid acts as an acid in liquid ammonia, just as it is in water. The Bronsted-Lowry concept also explains how ammonia acts as a base in water. The Arrhenius concept failed to accomplish this. When ammonia ionizes in water, water acts as the acid. As you can see here, this is a reversible reaction. Bronsted and Lowry define bases as substances that are capable of accepting protons. In other words, they define bases as proton acceptors. As a result, this concept defines an acid-base reaction as the transfer of a proton from an acid to a base. Students, please look at this hypothetical acid, HA. This acid releases a proton, H+, and its conjugate base, A-, when it dissociates. After accepting a proton, a conjugate base reforms the acid. When a base, B, accepts a proton, it produces its conjugate acid. Let us look at some real examples. As we have discussed, when ammonia reacts with hydrochloric acid, the hydrochloric acid donates a proton to the base. This results in the formation of ammonium plus and chloride ion. When hydrogen carbonate and hydroxide ions react, the hydroxide ion accepts a proton from the acidic hydrogen carbonate. As a result, carbonate ion and water are formed. Students, let us try an activity. We have learned that in order to identify Bronsted-Lowry acids and bases, we need to look for the proton donors and proton acceptors in each reaction. Identify the Bronsted-Lowry acids, bases, conjugate acids, and conjugate bases in each of the following reactions.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. Were you able to identify the acids, bases, conjugate acids, and conjugate bases in each reaction? In reaction A, ammonia is the base and ammonium ion is its conjugate acid. In reaction B, phosphoric acid is the acid and dihydrogen phosphate minus is its conjugate base. In reaction C, sulfite ion is the base and hydrogen sulfite minus is its conjugate acid. Students, it is important to note that all Bronsted-Lowry bases are not Arrhenius bases, but all Arrhenius bases contain only one kind of Bronsted-Lowry base, the hydroxide ion, OH- ion. This is because all Bronsted-Lowry acids are capable of donating a proton in all states, and all Bronsted-Lowry bases are capable of accepting protons in all states. Students, as a final activity, please define an acid and a base in terms of the Bronsted-Lowry concept. Also, explain how protons are transferred in acid-base reactions.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. It is nice to see you again. I am sure that you had no difficulty completing this activity. Let us discuss the answers now. According to the Bronsted-Lowry concept, an acid is a substance that donates a proton to some other substance. A base is a substance that is capable of accepting protons. Bases are proton acceptors. Acid-base reactions are the transfer of a proton from an acid to a base. The acid releases a proton and forms its conjugate base when it dissociates. After accepting a proton, a conjugate base reforms the acid. When a base accepts a proton, it produces its conjugate acid. In today's lesson, we learned how to define acids and bases in terms of the Bronsted-Lowry concept. We also learned how protons transfer during acid-base reactions. We learned how to identify acids, bases, conjugate acids, and conjugate bases in given reactions. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.